Hello, my name is Jack, and today I will be showing you how to solve this proof I made. First, we'll start out with what we need to prove, which I have right here. So the first things that we need to prove are that line segment BG is congruent to line segment HE, and that triangle EHF is congruent to triangle BGA. Our givens to help solve this, is that angle CGD is congruent to angle DHC, angle AGC is congruent to angle EHC, line segment AB, line segment EF, and line segment CD are all parallel to each other. Angle CEH is congruent to angle DBG, and that angle CFE is congruent to angle DAB. Alright, now that we have that out of the way, I will point out where each of these givens are on the diagram. I have already marked them, and you may pause the video at this point if you would like to see them and figure them out for yourself. I'm going to point them out right now, though. So, our first one, going a little bit out of order, is that AGC, which is right here, AGC, is congruent to EHC. Next, we have CGD, right here, this angle, is congruent to this angle here, CHD. Next, we have our parallel lines here, here, and here, and our angle CEH and angle DBG. We also, one last thing, have CFE right here. CFE is congruent to DAB. Alright, so the first thing we're going to prove is that line segment CD is congruent to line segment CD. So, of course, this is fairly easy. So we have line segment CD here, and we simply put this here. We prove that line segment CD is congruent to line segment CD by the reflexive property of congruence, which states that a line segment is congruent to itself. Next, now that we have that, we prove that angle DAB is congruent to angle CDA. So, angle DAB is congruent to CDA. So we have these two angles congruent to each other. We can prove this by the alternate interior angles theorem, which states that when you have two parallel lines and a transversal, which is a line that intersects two parallel lines, the transversal forms two angles within the interior of the two parallel lines. The two interior angles alternate of each other on the interior sides are called the alternate interior angles, and they are congruent to each other. Next, using the same theorem, the alternate interior angles theorem, we prove that CFE is congruent to DCF. Those are angles, by the way. So CFE is congruent to this angle here, which is DCF. There we go. Next, we can prove that DAB congruent to DCF, so that this angle is congruent to this angle, and we prove this by the transitive property of congruence. The transitive property of congruence states that if you have two sets of congruent angles, the two sets of angles will be congruent to each other transitively. Basically, meaning that if you have one congruent angle that's congruent to two other things, then the two other things that it is congruent to are also congruent. So since this angle is congruent to this as well as this, that makes these two congruent to each other. Therefore, we can prove that these two are congruent. Next, we use substitution, which basically means that we substitute out one of these for a different angle, which still means the same thing, though. And we can prove that angle DCF is congruent to angle CDA. So, angle DCF, DCF is congruent to angle CDA. So, these two are congruent to each other. Now that we have proven that all of these angles are congruent and this side is congruent, we can now prove that triangle CGD is congruent to triangle DHC. How we prove this is by angle-angle side congruency, which states that when you have two pairs of congruent angles next to each other, and one set of congruent lines on either side of these two congruent angles, then the two triangles are congruent. So we have our side here and our two angles. Therefore, these two are congruent to each other. Next, we are going to prove that line CH right here is congruent to line DG right here. So we prove these like this because of CPCTC, which stands for corresponding parts of congruent triangles are congruent. This essentially says that if you have two congruent triangles, that means that every corresponding part of each triangle will be congruent. Basically, for instance, how CD is congruent to CD, this can be proved by the reflexive property here, but because we know that these two triangles are congruent, we can now prove that this is also congruent because of CPCTC. We are going to prove that angle AGC is congruent to angle BGD by the vertical angles theorem. So, AGC is right here and BGD is right here. So it's these two angles. I'm going to mark these as congruent. So what the vertical angles theorem states is that when you have two intersecting lines or line segments that are both straight, the two pairs of angles that will be in them, the two pairs of opposite angles, that is, will be congruent, meaning that this angle will be congruent to this angle and this one to this. Next, we're going to prove that angle CHE right here, CHE is congruent to BGD. So CHE right here is congruent to BGD, and how we can prove this is by the transitive property of congruence. Now, again, using our givens and what we've proved already, we are going to prove that triangle CHE is congruent to triangle DGB using the same angle-angle side congruency statement. So, CHE right here is congruent because of this angle here, and this line here, angle-angle side. It is congruent to this triangle here, BGD, because of this angle here, which corresponds to this angle here, which corresponds to this one, and this side here, which corresponds to this. Next, we are going to solve one of the things that we need to prove, which is that line segment HE is congruent to line segment BG. So I've already marked these right here and here, and we can prove this by CPCTC. Now we are going to prove that angle CHD is congruent to angle EHF via the vertical angles theorem. So we have angle CHD right here is congruent to angle EHF, which is right here. So this angle here. So we will mark it like that. Next, we will prove that angle CGD is congruent to AGB. So CGD right here is congruent to AGB right here. So we will mark that with a single line as well, seeing as these are both single lines. Now we are going to use the transitive property of congruence to prove that angle AGB is congruent to angle CHD. So angle AGB is congruent to angle CHD. So this angle is congruent to this angle because of the transitive property of congruence. Next, we are going to use substitution to prove that AGB, again, this angle, is congruent to angle EHF right here, so that these two angles out here are congruent. Our final step is to prove that triangle EHF is congruent to triangle BGA via, again, the angle-angle side congruency. So we have, here's our first angle, which corresponds to here, so our second angle, which corresponds to here, and our side, which corresponds to here. Thank you very much for watching my proof and how to solve it. I wish you a good day and good luck.